Geometry students, since you already know what was in lesson 5.5, this video is going to be a little bit different than it normally would be. So we have these two theorems. I'm not going to call them theorem 510 and 511. This one I'm going to say if a side is longer than the angle opposite the longer side is larger, so I'm going to write it this way. If I have a triangle where this side is longer than that, then the angle opposite that bigger side is larger than that angle. And then down here, I'm going to write this theorem. If the angle here is larger than that angle, then the side is bigger than that. Notice I try to draw a scaling triangle when I do that. I think it's a fairly intuitive theorem. I think it's kind of obvious. So I'm not too worried about the proofs, but they could be interesting to look at. I encourage you to do that. Next theorem is the triangle inequality theorem. And I talked about the importance of being able to write all three of these equations. And all three of them have a place. All three of them have something that you may need when you're solving a problem. So what I'd like to do today is, or in this video, is go over two of the harder questions in the classwork from Thursday. So this problem says, use diagram at the right. Suppose that XY bisects angle WYZ. So this angle is the same as this angle. Excellent. And then list all 6 angles from smallest to largest. Explain your reasoning. I said this a couple times, and I got to reiterate. The two theorems we just have talked about have only worked for one triangle. So I'm going to draw a triangle XYZ. It looks something like this. And I know this is X, and this is Y, and this is Z. And I know this is 17, and I know this is 18, and I know this is 15. So right away, I know angle XYZ is the largest. Angle XYZ is the largest. Followed by angle YXZ. Angle YXZ. And then the smallest angle, so this is the biggest, this is the next, the medium, and then angle Z would be the smallest. Good. I'm now going to draw triangle WXY. So here's triangle WXY. Here's a W, here's X, here's Y. And I know that this side is 15, and this side is 14, and this side is 12. So I know this angle is the biggest, because it's opposite the biggest side, so angle W. And then I know this angle is the next biggest, and that would be angle XYW. And then the smallest angle is angle YXW. Angle YXW. Now, the angle in the middle here is the same as the angle here that's the largest, right? XYZ is the same as XYW. So what I can say when I start to order these is right now I know this is the biggest, followed by this, then this, and now really I've got to try to figure out which angles are bigger here, right? Of those three, I need to figure out what the smallest one is, what the biggest one is, etc. So here's what I'm going to do, and I actually got this from 10. I saw what 10's work was. So 10 looked at this triangle and he said, hey, you know what I know about angle Z? I know angle Z is equal to 180 degrees. Sorry, the measure of angle Z is equal to 180 degrees minus the measure of angle YXZ minus the measure of angle XYZ. And then over here, do you know what I know about angle YXW? Is that the one I want? YXW? Yeah, that's what I want. I know the measure of angle YXW is equal to 180 degrees minus the measure, I want to make sure I have these right. Yep. The measure of angle, so YXW is less than angle YW, which I'm actually going to call XYZ. I'm going to call it that because it's the same as that angle, and minus the measure of angle W. Good? Now, if I put this here, it's the same as this and this. Good? So what I know is that the measure of angle Z is this number, whatever that number is, and it's in both, minus this. And I know the measure of angle YXW is this number minus the measure of angle W, which is the largest angle in the picture. That means this has to be the smallest angle. It has to be smaller than Z. So now I know that this is the smallest. And so what I can say, if I order these from smallest to largest, I know it goes angle YXW, followed by angle Z, followed by angle YXZ, followed by angle XYZ, which is equal, the measure is equal to the measure of angle XYW. And then last angle, the largest angle, is angle W. So it's not straightforward how we could figure out here and here, but we were able to kind of write some things out. And I'll tell you, I got that from 10. So great job, 10, on the challenge question. And thanks for showing me how to do that. The next problem I thought was actually pretty easy based on the in-class examples. If I just write the three equations here, so I pick any two sides and I say those two sides have to be bigger than the third. So 6x minus 11 plus 3x minus 1 has to be bigger than 2x plus 3. And I know that 3x minus 1 plus 2x plus 3 has to be bigger than 6x minus 11. And lastly, 2x plus 3 plus 6x minus 11 has to be bigger than 3x minus 1. If I solve all three of these, so here I get a 9x minus 12 is bigger than 2x plus 3, 7x is bigger than 15, I get x is bigger than 15 over 7. Solving the next one, 5x plus 2 is greater than 6x minus 11. I get x is smaller than 13, so I'll write that way. X is smaller than 13. And lastly, I get 8x minus 8 is greater than 3x minus 1, so 5x is greater than 7. So x is greater than 7/5. What I have to do now, and I like the number line for it, is think about where all three of these inequalities are true. X is greater than 7/5. That's a little bit bigger than 1. So here's the number 1, and here's 7/5, and it's pointing that way. X is less than 13. 13's way out here, so that's pointing this way. And then lastly, x is bigger than 15/7. That's a little bit bigger than 2. So here's 2. 15/7. That's pointing this way. And now when I put them all together, it looks like this 15/7 is restrictive on the low end, and it looks like 13 is restrictive on the high end. So x has to be between 13 and 15/7. There you go. That's how you use those two theorems effectively. Thanks for watching the video. I'm sorry it was a couple days late. Busy week. I appreciate your generosity. Peace.